Okay, so this is something that we had talked about earlier in the year when we were talking about multiplying and dividing multi-digit numbers. But it's coming back because, as you know, that fractions are related to division, and so we can't forget that. We can't forget this. So this is the graphic organizer that we use. There's different types of multiplication problems and division problems, just like there's different types of addition and subtraction problems. But the one that we've been focusing on the most this year has been what's called equal groups problems. So these are problems like this where you have, for example, there are 16 letters in each box. If there are 320 letters in all, how many boxes are there? So in this case, the kids have learned you underline any number and whatever that number is describing. So 16 letters and 320 letters. And we also have looked to see where if it says like each or every or per, or any way that it is grouping things. So in this case, we're going to circle each in box. And in all is something also that we want to look at. That doesn't mean, oh, it's in all. It says in all. That means we definitely multiply. And a lot of kids think that. But if it has it in the problem, it is worth looking at because it's an important part of the problem. It doesn't mean that you multiply. It just means it's a part of the problem. So in this case, we look and we say, okay, we've got letters and we've got boxes, right? So we have to figure out what our group is. And usually you find our group is whatever is the each or every or per or one or a, whatever is, however it's being grouped together. So in this case, it's each box. So our group is box. And so that means the other thing that we're talking about is letters. So both of these must be letters. And the reason we put an oval and rectangles is because it helps us see, okay, once you figure out this one, then the other two are the same. Usually they figure out the group first. So in this case, it says we have 16 letters and 16 letters in each box. So that must be the letters in each group. So we're going to put that here. And in this case, it says 320 letters in all. Well, in all tells us that that is total. And of course, we look at our question, which says how many boxes are there? Well, that's what we're missing, is boxes. In this case, we're missing one of our factors. And when we're missing one of our factors, this would tell us that we have to divide. So in this case, we would need to know that we divide our number in each group into our total. And the important thing is the kids are all going to say, or they're used to saying, well, you always are going to divide the bigger number by the smaller number. And in this case, you actually do. And they would figure out that this goes into it 20 times. In this case, you actually do. But as we're going to see in fractions, that's not always the case. What we need to learn, or what we need to shift our focus to, is that we're always going to divide the factor, one of the factors, into, in this case, what would be the product, right? So the total. So whatever the total is, that is what we're going to divide into. And our divisor is going to be whatever factor we have. Okay, and that's going to be really important with fractions. So I'm going to keep this up here. I can find my eraser. Keep this up here and take a look at another problem. So in this case, we have 12 students that are sharing 4 sandwiches. 12 students are sharing 4 sandwiches. Clearly, we're looking at students and sandwiches. And it says, how much of a sandwich does each student get? Each student, that helps us see how we're grouping. Okay, so we're going to put as our group, student. And that must mean that both of these are, you got it, sandwiches. So in this case, we have 12 students. Well, that's easy to find. 12. In this case, it says 4 sandwiches. Now, we have to ask ourselves, Is this 4 sandwiches that each student gets? Does that say that? Well, let's look back at the problem. Does it say each student gets 4 sandwiches? No. In fact, if we look at our question, it says how much of a sandwich does each student get? So that's our question mark. So that means how many sandwiches do we have at this picnic or luncheon or whatever we have? We only have 4 sandwiches. That's our total. So in this case, a lot of kids, if they get to this point, will think, okay, well, I'm just going to do it like this. And it goes into it 3 times, and that's right. Now, what if they substitute it back in? They'll see that 12 times 3 does not equal 4. But hopefully, even before you get to that point, you'll see, wait a second, I've got to do 4 divided by 12. And that's a fraction. 4 divided by 12. Now, rather than actually figuring out the decimal of this, we can just look and say this is a fraction. And what is wrong with this fraction? Well, it's not in simplest form. What can go into both 4 and 12? 4. So in simplest form, it would be 1/3. Each person is going to get 1/3 of a sandwich. And if you draw it out, the 4 sandwiches, and you divided them up, you would see that to get 12 equal pieces for the 12 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they would only get 1/3 of the sandwich. That makes sense. Okay, so let's try this next one. Oops. Okay, I'm going to erase this. In this case, we have 20 teachers are sharing 8 plates of cookies. It's a very lucky teachers. They get 8 plates of cookies. It says how many plates of cookies does each teacher get? So let's underline 20 teachers, 8 plates of cookies. How many plates of cookies does each teacher get? So in this case, our group is going to be teachers. In this case, our number in each group is going to be, we could say plates of cookies. I'm just going to write plates.